In 11.7, you're going to be learning about standard deviation. So far we've learned about measures of central tendency, and that includes mean, median, and mode. And we've also started to talk about measures of variation, which include range and IQR, or interquartile range, or Q3 minus Q1. Measures of variation basically describe how the data is spread out. And today we're going to kind of build on that by talking about variance and standard deviation. These are measures showing how much data values deviate from the mean or our average. To find variance and standard deviation, just kind of go through step by step. First, you would find the mean or average of all of however many values you have in your data set. Then you would find the difference between each value and the mean. Then you would square that difference. Then you would find the average of these squares. So this is called the variance, and it's usually described by a little cursive lowercase o squared. And then to find the standard deviation, you just take the square root of that value. So take the square root, that would be your standard deviation. So let's figure out what the mean, variance, and standard deviation are of these random values. So to make this a little bit easier, we could make a table just to kind of organize our data. First, in that second column, we're going to find the mean, or the average. So we're just going to add up all of these values and divide by 5, because we have 5 values. And we get 7.4. So I'm going to put 7.4 in every value for that second column. And that's going to be helpful, because now in this third column, I'm going to be taking my x minus my average. So in this first row, I'm going to do 6.9 minus 7.4, and I get negative 0.5. And I'm going to do the same thing for the rest of the values for this column. So subtract, and I get these values. And then finally, for this last column, I take that value and I square it. And then I'm done. Finally, now I could find the variance. So for the variance, I'm going to add up all of those values squared and divide it by 5, because that's how many values I have in my data set. So I'm going to add up all these values in this last column. I get 11.3, and I'm going to divide it by 5. So my variance is 2.26. And then finally, to find the standard deviation, I'm going to take the square root, and I get 1.5. Now, we can do this all in our calculator, so for the most part, we are just going to use that, because that's way easier, it's way more efficient. So in your calculator, you would press Stat Edit to enter all the data that you have into your list, or into L1. Step 2, you'd go back into your calculator, go to Stat, Calc, select one var stats as an option, and then it's going to give you a bunch of information on that data set. And the important things that we're going to need for this section, that first thing there is going to tell you your mean or your average, which we see that little X with the overline bar over top. And also we're given our standard deviation, and that's going to look like that cursive O with a subscript of X. So now let's find, so the table displays the number of wins the Cleveland Browns have had in the regular season for the past 15 years. What are the mean and standard deviation of this data set? So we go from 2005 all the way to 2020, and it tells us how many wins we have. Now, we have a lot of data points. We're just going to use our calculator here. Our average, or when we enter all this data in, we do our one var stats, our average we find to be 5.125. So on average, the Cleveland Browns win about 5 games every season. And then the standard deviation tells us that each value averages standard deviation of 2.736. And how this can be helpful in example problem number 3, using that previous chart, within how many standard deviations do all the values fall? So this tells us for each season, how far away are we from the mean, or how much do we vary from the mean? So our middle are our averages here. Also in my plot, I put 0 to 16 because, or at least up until this year, we have 16 games in a regular season, so that's our whole range. Our mean is, as of right now, 5.125, so I put that there. And then I put an X for every season that we had, like for how many wins that we had. Now what I'm going to do, I'm going to go one standard deviation below the mean. So I do 5.125 minus my standard deviation, which gets me 2.389. And then I go one standard deviation above, so now I add that standard deviation. So all the values that fall within there are within one standard deviation of the mean. I can go out even further and see what's within 2 standard deviations of the mean. So if I go minus my standard deviation again, I get negative 0.347. So that kind of includes everything below because we can't have a negative number of wins. And then 2 standard deviations above. That's going to be around 10.5. So all those values that fall in that kind of category are within 2 standard deviations of the mean. And that just kind of helps us quantify how far away or how much something deviates from your average. So, for example, last year, the Cleveland Browns won 11 games that season. And when we see this all on a chart, you could see that having 11 wins is 3 standard deviations away from the mean. So that kind of quantifies how rare that is or how impressive that was last season. And that's where we're going to stop today.